Hello everyone, welcome to my channel CIC Topper Classes. Today we are going to discuss exercise 11 question number 1 to 8 of M.L.aggarwal class 9 mathematics, chapter number 11 midpoint theorem. So let us start solving this exercise here in this video.
Let us solve here exercise 11, problem number 1, first part. In the figure here given below, D, E and F are midpoints of the side BC, CA and AB respectively of triangle ABC. If AB is equal to 6 cm and BC is equal to 4.8 cm and CA is equal to 5.6 cm, then find the perimeter of the trapezium FBCE. So we have to find, so firstly to find the perimeter, we have to find the value of FB, EC and BC here. So we can simply write it as BC is given to us as 4.8 and second thing is FB. F is the midpoint of AB. So we have BF is equal to half of AB. Putting the value, we will get half into 6. This will be 3 centimeter from here. Now we have to find the value of CE, which will be again half of AC, as E is the midpoint. So half of AC will be half of 5.6. Here this will be 20 and we can write it as 28 divided by 10. This will be 5 and this is 1 4. So 14 by 5 centimeter. We can simply write it as um, 2.8 centimeter. Now the third thing here is we have BC equal to 4.8 centimeter and because FE and BC are parallel here, we can simply write it as FE is equal to half of BC according to the theorem. So this will be because the midpoint, if two points are parallel and F is the midpoint of these two sides, we have FE as half of BC. So this is the theorem. So this will be half into BC. Here is BC is equal to 4.8. We will put the value and this will be 2.4 centimeter from here. Simply we will find the value of trapezium FBCE from here. So we can find the perimeter as perimeter of trapezium FBCE. So this will be here FB plus BC plus CE plus FE. Here we will put all the values here. FB is equal to 3 centimeter here and BC is equal to 4.8 centimeter plus CE is equal to 2.8 centimeter and here this is FE. FE we have find here as 2.4. So this is 2.4 here. We will add these all things. On adding here we will get as 13 centimeter as the perimeter of the trapezium. So this is the first part which we have to find here. Now let us solve the second part. Now let us solve the second part of the first question. So this is we have to find the perimeter of DEF. We will cancel out. This will be 3 centimeter from here and this will be 2.8 centimeter and here we will get 2.4 centimeter. Now we have to find the perimeter, so simply we will add these things here. So perimeter of triangle DEF is equal to DE plus FD plus FE here. We will add this 3 plus 2.8 plus 2.4 from here. So this will be 12. We will carry 1 and 3, 5, 6, 7, 8. 8.2 centimeter is the perimeter of triangle DEF. So this is the answer of the second part here. Now let us solve the second part. In the figure given below, D and E are midpoints of the side AB and AC respectively. If BC is equal to 5.6 centimeter and angle B is equal to 72 degree, then we have to compute here DE. As these are the midpoints, we can simply apply the theorem here that if DE and BC are parallel, we have DE as half of BC. So simply here we can write it as DE, D and E are the midpoints of sides AB and AC. So simply we can write it as BC as 5.6 centimeter and angle B is equal to 2 degree. So here we can write the first part as DE, which will be half of BC by the theorem. If DE and BC are parallel, so it will be half of 5.6 means this BC. We will cancel out this part and we will get 2.8 centimeter on cancelling. Now, the second part which we have to find is angle ADE, means this angle we have to find. And angle B is the corresponding angle, so we can say that angle DBE is equal to angle B by corresponding angle here. So these two are corresponding angle we have. So this is the corresponding angle. We can simply say that angle B is given to us, which is 72 degree. So angle ADB, from here we can say that it is also ADE, sorry, this is ADE. This is also 72 degree. Hence, this is the answer of the second part and this is the answer of the first part in this question. Solve the first third part here. In the figure here, third given below, D and E are midpoints of AB, BC respectively. Means this D and E are the midpoints of AB and BC respectively, and DF is parallel to BC. If DF is parallel to BC, we can simply say that F is the midpoint of AC here. So this is given to us. Then we have to prove that DBEF is a parallelogram, first thing. So we can simply say that DF is parallel to BC. So we can write it as DF is, first thing is DF is parallel to BE. Now from here we can simply write the second thing, which is if here this FE is parallel to AB, means this is here only, so we can write it as FE as parallel to AB. From these both things, first and second, we can simply say that this DBEF, if this is parallel to this and this is parallel to this, we can say that DBEF is a parallelogram here in this question, hence proved from here. Now let us solve the second part here, which is we have to prove that F is the midpoint of AC. So simply we have to write it AC as 2 into AF. So it will be 2 into 2.6 here, which will be 5.2 centimeter from here. So this is the final answer of the second part here in this question. Because F is the midpoint, so 2 into AF will be the value of AC here in this question. Let us solve the second question here in this exercise. We have to prove that the four triangles formed by joining in pairs, the midpoints of the sides of a triangle are congruent to each other. We have to prove this. So simply we can write in triangle here ABC, we have D, E and F as the midpoint of AB, BC and CA respectively. So from here we can write it as DE is parallel to AC or DE is parallel to FC. Similarly, we have DF. DF is parallel to EC, we can say. So hence, if two sides are parallel, DF is parallel to EC and this FC is parallel to DE. So simply we can say that this DECF is a parallelogram here in this question as proved. Thus two four sides are means these two sides are parallel and these two sides are parallel. Similarly, we can see that this FE is a diagonal, means FE is a diagonal which divides the parallelogram in two congruent triangles, which divides the parallelogram in two congruent triangles, which are here triangle FDE is congruent to triangle FEC. Similarly, we can prove this only in the this ADEF parallelogram and this FDBE parallelogram. So here also we will get as triangle DBE is congruent to triangle DEF. So this DBE is congruent to angle DEF. And similarly, this is the first thing, this is the second. And now in this parallelogram, we can prove that triangle ADF. Similarly, we can prove it's congruent to triangle DEF. So this triangle DAF is congruent here with DEF. So this is the here this is DBE and DBE and DFE. Sorry, this is D here, triangle DEF, and this is DEF. So this is the third thing. From these three equations, we can simply say that these four triangles are congruent, which are triangle FEC is congruent to triangle ADF. This is congruent to triangle DBE, and this is congruent to triangle FDE. So from these three equations, we can simply say here. So this is the final answer which we have to prove in this question. Hence proved from here. Let us solve the third question here. If D, E, F are the midpoints of side AB, BC and CA respectively of an isosceles triangle ABC, then prove that triangle DEF is also isosceles. To prove that, firstly we will take here as, because DE is parallel to AB, so we can simply write, because D and E are the midpoints of the sides respectively. So DE is equal to half of AB here. And again the second thing is this FD. FD are also the midpoints of BC and BA. So respectively we can say that DF is parallel to AC, and we can write DF is equal to half of AC by the theorem. From these first and second, here this is also given that it is an isosceles triangle ABC. So it is given AB is equal to BC here. This is the given part. We can simply say, they say that if AB is equal to AC, DE is equal to DF from the first and second equation. So this is from first and second. As D is equal to DF, we can simply say that this DEF is also an isosceles triangle, because the two sides of an isosceles triangle are equal. Hence, triangle DEF is an isosceles triangle here, which we have to prove here in this question. So this DEF is an isosceles triangle, hence proved from here. So this is the final thing which we have to prove here in this question. Let us solve the fourth question here, in which the diagonals AC and BD of a parallelogram ABCD intersect at O. If P is the midpoint of AD here, then prove that PO is parallel to AB. So simply we can write here, because it is a parallelogram, so diagonals bisect each other. Means here we can write AB is equal to OD, that is O is the midpoint of BD. So O is the midpoint of BD here. And now in triangle ABD, we can simply write P and O is the midpoint of AD and BD respectively. Means here in this triangle ABD, we have P and O as the midpoints of AD and BD respectively. So we can write PO is parallel to AB, and from here only PO is equal to half of AB by the theorem. So we can simply write that the first part is proved here, in which we have to prove that PO is equal to parallel of P. Now, the second thing which we have to prove here, PA is equal to half of CD here. As it is a parallelogram, we have AB is equal to CD, because ABCD is a parallelogram here. So from here only, putting it in the first part, we can simply write it as AB is equal to CD. We will put in this equation here. Let it be first equation. So on putting, we will get PO is equal to half of CD. This is only we have to prove in the first and second part in this question. So this is the solution of the fourth question. Hence proved from here only. Now let us solve the fifth question. In the adjoining figure, ABCD is a quadrilateral in which PQRS are the midpoints of AB, BC, CD and DA respectively, and AC is its diagonal. Then show that SR is parallel to AC and SR is equal to half of AC. So simply we can prove the first part as by midpoint theorem because these are the midpoints of S and R of AD and DC. So simply we can write SR is parallel here to AC. We can simply say, and this we can write it as SR as half of AC by midpoint theorem. So put it as the first equation here. So by midpoint theorem we can write it as. Now, the second thing which we have to prove in this question is PQ is equal to SR. So simply in this we have tried to make of ADC. So it is triangle ADC. Similarly in ABC, triangle ABC, we can write it as PQ is parallel to AC, and from here only we have PQ is equal to half of AC by midpoint theorem only. Put it as the second equation. Here we have to prove that PQ is equal to SR. Simply from first and second equation, we can write it as um, PQ is equal to SR, as this is equal to half AC and this is also equal to half AC. Hence proved from here. Now let us solve the third part here in this question. Third part is PQRS is a parallelogram we have to prove here. So simply we can write it as, from here only, from the second part we can write PQ is equal to SR here. We have proved that this PQ is equal to SR and PQ is parallel to SR also. So we can simply write it as PQRS is a parallelogram from the first and second part here. So this is only we have to prove here, hence proved from here. Now let us solve the sixth question here. We have to show that the quadrilateral formed by joining the midpoints of the adjacent sides of a square is also a square. So to prove this, firstly we will take here in angle ACD and triangle ABC. We can write that GH is parallel to AC and this EF is parallel to AC. So simply from that only we can write as GH is equal to EF is equal to half of AC, and again in triangle ABD and triangle DBC we can simply write again that HE is parallel to DB and this GF is parallel to DB. So we can write HE equal to GF equal to half of DB from here. So simply, and as we know that the angles here means this AC and DB lines are diagonals are equal because the diagonals of a square are equal. So this is the diagonal of a square. We can simply write this part here as AC is equal to dB here, and from this only we can write that EF is equal to GH here and this is equal to HE and this is equal to GE. From here only we have, because the diagonals of parallelogram, because this is from here we can say that EFGH is a parallelogram. So it will be in triangle GOH, means this GOH here and GOF, as we can write this GOH and GOF, we have it as OG is equal to OG because this is common in this triangle. So let us write here in triangle GOH and triangle GOF we have OH is equal to OF. OH is equal to OF because here we have diagonals of parallelogram bisect each other. Because they bisect each other, diagonals of being diagonals of parallelogram, we can simply say that this and this are equal, and here we have OG as common, so this will be also equal. This is common here, and from this GH is equal to GF as from the this thing, because DH is equal to GF here, but this is GF here, so we can simply write it here. Now GH is equal to GF from here, and from this only we can prove that GOH and is congruent to triangle GOF from here by SSS rule of congruency only, and we have GOH plus GOF equal to 180 degree, and as these are equal or congruent, we can say that 2GOH is equal to 180 degree, and from here only we will get angle GOH is equal to 90 degree, which is equal to GOF also. So here we can prove that diagonals of parallelogram means, here this is diagonals of parallelogram ABCD, diagonals of parallelogram here, which we have to prove that it is a square ABCD, bisect each other uh, and perpendicular to each other. So they are bisecting and they are perpendicular to each other, as we have proved here. So we can simply write it as um, EFGH is a square here. So this is EFGH is a square, hence only. Hence proved from here. Let us solve the seventh question here. In the adjoining figure, AD and BE are medians of triangle ABC. If BF is parallel to BE here, then we have to prove that this CF is equal to half of AC. Here BE is a median, so we can say from here BE is median. In median we have um, a half of EA is equal to AC. Sorry, EA. We can write it as AC. EC is equal to half of AC. And here in the second part, because this is also the midpoint, F is the midpoint of a triangle, here line EC, so we can write EC, FC is equal to half of EC. And now we will put in this first equation, we will put in the second equation. So on putting first in second, we will get FC is equal to half of half AC. Hence, we will get 1 by 4 AC, which we have to prove in this question. Hence, prove from here. So, this is the final answer which we have to prove in this question, seventh question. Now let us solve eighth question. In the adjoining figure, ABCD is a parallelogram and E and F are midpoints of the side AB and CD respectively. The straight lines AF and BF meet at G. The straight lines ED and EC at G and H. Prove that triangle HEB here. This HEB is congruent to HCF. So for proving this, we can simply write here in the first part as, because ABCD is a parallelogram, FC will be parallel to BE. So we can simply write that angle CEB is equal to angle FCE. Means this angle CEB is equal to angle FCE because of alternate angles. So we can write it as alternate angles. And in simplifying form also we can write it as here as CEB, that will be CEB. So we can write angle HEB equal to angle HCF. This will be angle HCF from here. Now again we have alternate angles here in EBF and BFC. So we can write it as angle EBH is equal to angle CFM by the alternate angles only. Let it be the first and let it be the second equation here. And EFF are the midpoints of AB and CD. So simply we can write BE is equal to half of AB and CF is equal to half of CD. Put it as third and fourth. Now, but ABCD is a parallelogram, so simply we can say that AB is equal to CD here, because ABCD is a parallelogram. As half of AB and half of CD are equal, so we can simply write BE. From here only we can write BE is equal to CF. Means from this fifth equation we can write from fifth. And now we have to prove that this H triangle HEB and triangle HCF are congruent. To proving this, firstly in here HEB and triangle HCF, we can firstly write as these HEB is equal to angle HCF from first, and this is EBH here is equal to angle CFM for proving it congruent. Now the third thing is here BE is equal to CF. From these first, second and third thing, we can simply prove out that this triangle HEB is congruent to triangle HCF. This is only we have to prove in this question. So we can write hence proved from here in the first part. Let us solve the 8th second part, in which we have to prove that this GEHF is a parallelogram. To prove that, since E and F are the midpoints of AB and CD, so we can simply write it as AE is equal to CF here, because AB is equal to CD. As AB is equal to CD, A is equal to FC also. Now AE is parallel to CF here. FC means, so we can simply write it as AE is equal to CF, and AE is parallel to CF. As AECF, we can simply write from here, from this information, that it is a parallelogram. Now G and H points on the AF and CE, so we can simply and CE, so we can simply write here also that GF is parallel to EH here, because this is GF and this is EH, so this is parallel here. Similarly, we can prove here also, as we have proved in this, that here GFHE is a parallelogram. From here only we can prove. Now point G and H on the line DE here, and this FB. So we can write respectively that GE is parallel to HF. This is the let it be the first part here, and this be the second part, and this be the third part here. GE is parallel to HF. From here we have concluded, and from this 2 and 3 only, from second and third we will get as, because GE is parallel to HF and GF is equal to parallel to HE. So simply we can write GEHF is a parallelogram.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.